Today, I would like to connect the conference theme Science Technology for Human Potential with urban planning. I think innovation often begins with understanding everyday life, the land we live on, the people around us, and the cities we build. Urban planning in this sense is one way of understanding the world and everyday life. Not only understanding, but also planning decisions shape our world. Today, I want to talk about how urban planning can dramatically shape our world through the case of a neighborhood in Williamsburg, Brooklyn. I hope you all might be familiar with this neighborhood. Next slide, please. When I first came to New York 2 years ago, I visited Williamsburg in Brooklyn. I saw modern high-rise towers standing next to old industrial buildings. As an urban planning student, I became curious about what caused such a dramatic transformation from an industrial area to a current neighborhood with mix of old and new. Next slide, please. This led to my project called Gentrification in Williamsburg, How Rezoning Changed the Neighborhood. I asked four main questions: what intervention initiated the change, how land use changed, where new developments were built, and who lives in the neighborhood now. Next slide, please. Using sensor track data in ArcGIS, I conducted a spatial analysis to track changes between 2010 and 2020. The key turning point was the 2005 rezoning intervention, which allowed new residential and mixed-use development along the waterfront. Next slide, please. After the rezoning, high-rise mixed-use buildings and higher-income residents increased, while industrial land use and lower-income residents decreased. This research shows how a single planning decision can reshape both the physical landscape and the social structure of a neighborhood. Next slide, please. So coming back again, understanding these changes reminds us that innovation is not only about a new technology, but also about policies and designs that shape our world. Thank you for listening, and I would like to discuss further during the poster session and more maps about this. Thank you.
Today I will be presenting the research I did along with Dr. Bunjum Kim here about the removal of microplastics from water using ferrofluid with graphene oxide composite. Microplastics have become a major environmental threat because they threaten our ecosystems and contaminate our most important resource, which is water. Microplastics are extremely small plastic particles composed of the same synthetic polymers found in larger plastics such as polyethylene and polyethylene terephthalate, commonly known as PETs. So these particles are now found everywhere, like sea, rivers, soil, air, and even our drinking water and food. Because of their small size, they're extremely difficult to remove using traditional water treatments, and as a result, wildlife consumes them unintentionally, which can lead to starvation and death. To address this problem, our research, we used nanotechnology-based solutions using ferrofluids. And ferrofluids are liquids that contain magnetic nanoparticles suspended in a carrier fluid. These nanoparticles have a large surface area that can bind into microplastics through chemical or physical exposure. Once the microplastics attach to ferrofluid particles, the mixture can be removed from water using a strong magnet, which is what we did, allowing a rapid and efficient separation process. Our research focused specifically on enhancing this process by incorporating graphene oxide, which is a single-layer carbon atoms arranged in a two-dimensional honeycomb structure. Graphene oxide has unique properties, including stability and a strong absorption capabilities. Based on these properties, our hypothesis was that the mixture of ferrofluid graphene oxide would capture the microplastics better in water than just ferrofluid by itself. And to test this hypothesis, we synthesized two materials, ferrofluid nanoparticles and a ferrofluid graphene oxide composite, which you can see in the picture over here. The fully black water was the one with ferrofluid only, excuse me, and the one attached, you can see the black parts attached to the water, to the magnet. That's the one with the graphene oxide. We then tested the samples containing the PET, polyethylene, the microplastics, and as you can see over here, the one with graphene oxide gave us better results, about 80-85% results. And this is our table, which we show the differences between in scales from the graphene oxide and ferrofluid only, and the one with graphene oxide and just by itself, sorry. During the experiments, ferrofluid particles attached to the microplastics were easily drawn, as you can see in the neon magnet. And it took some of them, well, in the graphene oxide one, took about, I want to say 5 minutes, which was quickly, when the the ferrofluid only one took about, I want to say 2 to 3 days to separate, and it wouldn't separate fully. Thank you so much.
Even though technology is growing up, human knowledge is the first. So basically, I'm studying the palindromic RNA structure to predict the RNA self-interaction. But why is RNA? So basically, many people understand the RNA is just genetic informatic delivered from the DNA to build the protein to cells, and that's so. But still, predicting the RNA dynamic structure is still remains a challenge. So we are aiming to build the prediction model to predict the RNA dynamic structure. So we also set the hypothesis to predict the RNA dynamic structure, secondary structure, and then we just found several features of the RNA structure, different interactions using the computational simulation, machine learning actually. So, and then we found the interesting feature in behavior from our designed RNA simple sequences. So from this data, we want to explain the different behavior from our RNA sequences using the thermodynamic simulations. So I hope I can explain more detail in my poster session. Thank you.
Thank you. Today I represent an ultra-low power sensing a finger and in-ear for SpO2 and blood pressure tracking. Organic semiconductors has advantages for wearables due to their flexibility and thinness and lightweight. Beyond OLED displays, research now focuses on integrating them into optical sensors to monitor vital signs like heart rate and blood oxygen saturation level. However, increasing brightness, luminance for better signal quality leads to a critical trade-off, which is higher power consumption and shorter device lifetime. To address this, we optimize the optical structure and arrangement of light source and the photo detectors to solve this problem. We present an integrated optical simulation framework. This method combines wave optics calculations within thin film devices and with a Monte Carlo ray tracing technique, tracing 1 billion rays through the skin model. This approach allowed us to correlate driving luminance, brightness, and the power consumption across various structures, ultimately identifying the optimal design point, which makes both luminance and power requirements are minimized. We use the vertically stacked tandem OLEDs and organic photo detectors to enhance fabrication yield. And the green OLED and red OLED are stacked vertically, allowing selective emission based on the biasing directions. The detailed characteristics of the device are shown here. As a result, we achieved high fidelity PPG signals and only 30 nits and sub 1 microwatt power consumption with an error of less than 2%. We successfully achieved simultaneously reduction in power and luminance, which is brightness, while extending sensor lifetime through proposed optimization. Finally, we applied our sensor to earbuds and successfully estimated blood pressure via synchronized multi-site sensing. Thank you for listening.
The maritime industry is a major carbon emitter, yet its 2050 net zero framework was recently delayed by a one-year adjournment at MEPC-ES2, the recent committee of IMO. So I investigated why this consensus-based structure often results in delay rather than decisive action. To investigate, I did analysis. First, I conducted a case study and deep comparative analysis with International Civil Aviation Organization called ICAO. ICAO successfully implemented the KSEA mechanism by focusing on offsetting incremental emissions, which minimize sovereignty concerns. In contrast, IMO's approach involved a direct carbon levy. This was perceived as a global tax, triggering much stronger resistance against this direct regulation. And second, to objectively verify these delay factors, I used 3 AI engines to quantify this course in 3 pivotal documents: MEPC 83, US Statement, and MEPC ES2. This allowed me to transform qualitative political rhetoric into a measurable issue influence index by these prompts, as you can see in the screen. The MEPC 83 recorded the high technical feasibility, showing early cooperation. However, the U.S. joint statement shifted the landscape, hitting a maximum point in economic impact by reframing the levy as a threat to their security. And at MEPC ES2, political sovereignty became the decisive trigger for the adjournment. As shown in this chart and the total radar chart, as economic impact and sovereignty concerns rose, and environmental necessity was effectively neutralized. Ultimately, this research suggests for the 2050 goals, we must prevent the consensus norms from being used as the geopolitical shield. I propose that international organizations should adopt more flexible regulatory methods and find the balance. I hope to see in the poster session for more details. Thank you for listening.
Today, I will present my research on the K-beauty supply chain and logistics structure in the United States. This study focused on how the rapid growth of K-beauty imports is influencing regional logistics network in the U.S. First, let me explain the background of this research. Over the past decade, Korean cosmetics have been extremely popular worldwide. In the United States, import of Korean beauty products has increased very rapidly. This growth is not just a temporary trend. It represents a structural expansion of the global beauty market. Because of this growth, it is important to understand how K-beauty products enter the US market and how the logistics network works. Therefore, this research asks 3 main questions. First, how have U.S. import of Korean cosmetics changed over time? Second, as these imports geographically connected in specific region of the United States? And third, what do these patterns mean for supply chain and logistics planning? To answer this question, I analyzed U.S. import data using HS code 3304, which represents cosmetics and skincare products. This data set covers the period from 2016 to 2025. This study combines trade trend analysis with GIS mapping to understand both import growth and geographic distribution. Overall, this research shows how combining trade data analyst and GIS analyst can provide deeper insight into global supply chain. Thank you for listening.